Simulation of a single phase diode bridge rectifier. In this design of single phase diode bridge rectifier, take one voltage source. So V sine from library take one V sine, and inside of V sine, so DC 0, AC 0, V of 0, amplitude is equal to, for example, here 5 volts, and frequency 1 kilohertz. Adjust like this, different type of parameters. Okay. So this is the source side, and then from library take one diode D1N4002 by entering this in this library, peaceful library D1N4002. Like this, take the element and place on the drawing sheet. Okay. So similarly, a resistor and voltage source like this connect the single phase diode with rectifier. Okay, and enter a labels like this. Here one and here zero. This is called ground is connected to the in this way. Na? So here neutral is called zero, and here 3 and 1, 3, 0 and 2 and 4 like this can enter labels on this schematic. After this, so you want to display the voltage waveform directly by running the simulation. Take one voltage marker and place here. So, and if you want to change the color of waveform, and then go to like this. So this type of waveform, and this type of color will be displayed on the input voltage. Similarly, to find the voltage across this load, resistive load, take one voltage marker and place on here, and then if you want to display the change the color, and go to mark color, and select like this colors. Okay, and then this is called input voltage waveform, and this is a output voltage waveform, and then run this icon X. Okay, like this you will get the voltage waveform, and here the 5 milliseconds na. So go to analysis and the setup, and change this time to 5 milliseconds to 2 milliseconds. 2 milliseconds, enter 2 milliseconds, and then close, and this run this second, and this is the our output voltage. So this is our input voltage waveform. This color is called, is our input voltage waveform. Okay, and this orange color is called our output voltage across the resistive load. So like this we will get the voltage. Okay, in this way we have to execute the single phase diode bridge rectifier, and then this by default by using these markers, so you will get automatically by run the icon, execute run this simulation icon, and then we will get voltage waveform, input voltage and the output voltage. And then if you want to give the expression by using expression, so we have to find the voltage across the load. So the load is connected in between 3 and 2. That's why we have to enter the expression V of 3 comma 2. So after running this simulate, and then new pop-up will be appear like this, and then go to trace and add trace. Write the expression V of 3 comma 2. Here this load is connected. The load is connected 100 ohms. Load is connected between 3 and 2. That's why enter V of 3 comma 2. V of 3 comma 2. Then we'll get this type of waveform. This is called our output voltage waveform. Okay, single phase bridge rectifier like this. Okay, and then how to find the average value and RMS value of this output voltage waveform. Okay, how to find average value and RMS value. So go to analysis. First run this. Simulate, and then go to trace and add trace under this. This take this icon AVG off. So average of V of the load is connected between 3 and 2, 3 comma 2, like this. Enter expression V of average of V of 3 comma 2, and then like this waveform, average output voltage waveform generated like this way. This is called average output voltage waveform. Okay, so this is a Average output voltage means here this is called waveform or final voltage will settle in this way. That means here maximum here. So if you want to display this average output voltage waveform, place like this cursor, toggle cursor by using toggle cursor, and place here the maximum average output voltage will be maybe 1.8 1.9. So the only fractions will be the difference 1.8 or 1.7 or 1.9. So like this you will get by calculating this average output voltage theoretically, and we have to verify that the average output voltage practically like this. So 1.8 8254 like this. This is called average output voltage. So in this way we have to find the average output voltage by writing the expression. Okay, and then next how to get RMS. So similarly go to trace and here RMS will be the one expression will be there. RMS average is over, and then RMS. So RMS of what is the expression? V of load is connected between 3 comma 2. So that's why write this expression RMS of V of 3 comma 2. Then RMS value of output voltage send it. Okay. So for this waveform, so RMS value, average value 1.8, but RMS value maybe here you will get maximum means go to enable toggle cursor and then place here marker. So 2.26 maybe fractions it will be changed 2.1 to 2.3 like this, only fractions change. 2.1 or 2.3 you will get this average RMS value of output voltage. Okay, this way we have to find RMS value and average value. Okay, and then if you want to display the current flowing through the load or source also, so if you want to find the current so this is called V3 na. So I of V3, so we will get expression current source current waveform. And also if you want to find the current flowing to the load, so I of V2. Okay, so similarly run this simulate and then go to simulate add a trace and I of V2. So I of V2 is called I of V2 is called current flowing to the 100 ohm resistor. 100 ohm resistor current flowing to the 100 ohm resistor is nothing but I of V2. Okay, understood? So I of V2 is called by this select this expression and then okay. So this is called current. Here 20 milliamps and here approximately here what is the value means by enabling toggle cursor and it will be this peak value that is called 34.773 milliamps is called source current peak value. Okay, positive peak. Okay, positive peak of 0 to here. This is called 34.773 milliamps. This is called source current waveform. I mean, that's called load voltage, current flowing to the load. This is called current. Similarly, so if you want to find the uh, average value of current, go to trace average value of ID1, then you will get like this. Approximately maybe 10 milliamps, 10 milliamps. So 9.4, 9.1 like this, 9.5, maximum 9.5. So this is called average value of load current. 9.4 milliamps is called average value of current. Okay, similarly, RMS value of current. So average RMS value of current means take this expression from this functions RMS. Okay, RMS value of ID1. Okay. RMS value of what is the current here? I of V2. RMS value of I of V2. That's why RMS value of I of V2. RMS, take RMS here. I of V2. Where is V2? This is called I of V2. And then that's this. and we will get this RMS value of current. Okay, so from this expression, from this way, so this is called average RMS value of current. Here, what is the maximum value? So by taking the cursor, and then 22.67 is milliamps is called RMS value of current for this source. Okay, I mean for this load 100 ohms load, and source voltage is called 5 volts and frequency 1 kilohertz. So corresponding this, so input voltages corresponding the load. So we are getting the current 22.67 milliamps is called RMS value of current. Okay, and then next source current. Source current. That source is nothing but our source where it is connected with source here. Source here, in between 1 and 0, this source is connected, and this source current means the dummy voltage source. By introducing one dummy voltage source, this voltage source voltage is equal to 0. That means I of V3 is called current flowing to the source. So then go for trace and add trace and I of V3. I of V3. So this is our source current waveform. Okay. Properties, go to properties and the width, change width. So this is called source current waveform. Okay, understood. So enable toggle cursor and then enable toggle cursor and press this icon, and then will be display like this. And this is called peak values. Here 34.866 milliamps is called positive peak current. Similarly, negative peak is also you will get minus 34.866 milliamps. Okay, so this is about the source current waveform of this single phase diode rectifier. And then next, if you want to find the current flowing to the diode, this diode, current flowing to the diode D1. So similarly, introduce one dummy voltage source and take one dummy voltage source VDC and press controller, and it will be rotated like this, and connect like this element, dummy voltage source. Okay, and then simulate. After simulation, this is called V4. Na? So I of V4 is called current flowing to the diode. I of V4. So this is called current flowing through the diode. So current flowing through the diode. So we are getting like this, just like half wave rectifier, single phase half wave rectifier. Current. This is called current flowing to the diode D1. And then how to find the current average value of current flowing to the diode D1? Similarly, go to trace and add trace, and then average value of AVG of D1. I of D1 is that is called I of V3. I of V4. I of V4. One voltage source is connected here, na? The dummy voltage source. That's why I of V4. Otherwise, directly you will get I of D1. Okay. So D1 is option is also there. I of D1, I of D2, I of D3. That means current flow with the D1. And then average value of I of V4. So in this way we will get also. Okay. So this is called average value of current flowing to the diode D1. From this expression, from this waveform, and you can get average value. So approximately same way. So here also 9 point something. So this is called 9.37 milliamps. So like this we will get the average value of and then similarly we have to find RMS value of diode current. Okay. So enter, go to trace and add trace, and then this RMS value. So take this expression from this RMS value, RMS value of RMS value. I have before, otherwise RMS value of diode D1. So like this voltage waveform generated, current waveform, and then final value of current is called here. What is this expression? Enable toggle cursor, and then it will be displayed. So 16 band 016 milliamps is called RMS value of source load current, diode current. So like this, we have to execute this experiment. Okay.